poor computer these days. She's
got osteoporosis.
she really does.
Yeah, she's got osteoporosis.
You can see that hip joint just exposed. My girlfriend's got the same laptop she got at the same time. It had a big old crack right here, so you couldn't shut this. It was just trying to like punch itself in the motherboard. So we were looking at like laptop repair shops or want to charge like $200 to replace this whole top shelf. Your dad's like, give me your laptop, super glue. Just super glued everything. No problems. Nice. Worked great. Every shop I was telling me, I'm like, yeah, we were thinking about maybe gluing it. They're like, don't do that. And if something bad does happen from it,
Just pick up.
it'll be time for a new laptop anyway.
Their computers last like 2-3 years anyway.
They're coming up on 3 years, so I'm thinking
It's about time.
it's about time. Especially because it's mine.
Hello, how are you guys doing? Well, I finished grading the midterm. Are you guys able to check your grades? Are there any particular questions that you want me to comment on? Or should I just share the solution for the exam? Go ahead.
So on question 2,
Question 2.
it has to do with the static versus dynamic scoping. So I missed a point because it's not that the variable of R changes, it is a different R entirely.
Yeah.
So that's because this procedure small declares a new variable at the start of it. Am I understanding that correctly?
Yeah, so let's evaluate this as a static typing first, right? You have R being referenced here. So you do have an R in the outer scope, right? This is the, so we are referring to this R here, right? And we call show. Show will print R. And because R is not defined within the scope here, we're referring to this R here, right? So we get 0.25.
Are you trying to share your screen?
Oh, okay, I'm sorry. I just assume that it's shared. Okay. So again, we started doing the static typing evaluation. So we have 0.25 assigned to R. We're referring to this R here. And then we call show. Show references R, but R isn't defined within the scope. So we're still referring to this, let's say, program scope R, right? Then we have a call to small. Small declares another R, right? So there's an explicit declaration here. And this R here, there is another R, right? So this R, it's the small r, or the R defined in the small procedure. Not this R, which is the dynamic, the program level one, right? So when we call R, we another variable was created, local variable within this procedure small scope. But then we call show, and well, how R is going to be result here. It's a static typing. You should look at the scope that encompasses the show procedure, the larger scope, which is the dynamic. So we're talking about this R here. That's why we get 0.25, right? So the dynamics typing, it's different because when we get to this point where we are evaluating show, right? We're not going to look at the larger scope. We're going to look at pretty much, we're going to look at the call stack and the R that's going to be used here is the, let's put it this way, the last R that was evaluated, which is the R from small, because small calls show, right? So, yeah, I remember taking, I think just 1 point,
Yeah.
just 1 point, based on, and it wasn't just you. I remember I had from other students, I also deduct a point based on the wording and the explanation. If you were talking about you're not modifying the R, basically, I don't remember exactly the situation, but it made it sound like you are saying that sometimes this R is modified, sometimes it's not. And I think the key, more important fact is talking about different R's. There is an R defining this, the dynamic level, the dynamic program level, and there's another R defining the small procedure. But I'll be glad to take another look if you want to rephrase and like justify the way you wrote.
Now, I think I missed that line where it declared a new variable R, and I said that the value changed, so I get why I missed that point.
This line here, right?
Yeah, R, yeah, within small, yeah, I didn't see that there was a new variable declaration
Okay.
while I was going through the problem, so I get why I missed that point, that makes sense.
Okay.
So thank you for explaining that.
Good. Any other comments about this particular question here? Anybody want to talk about it? People that are online, have any questions related to this one here? What do you guys think about the exam in general? You think it was too long, too short?
I feel like I can
Short,
it's
A bit long.
Oh, too long?
Yeah, just a bit long.
Okay.
Something that surprised me about it was that every question was a short response.
Mhm.
I'm used to seeing the format to be kind of a mix of short response and multiple choice kind of questions.
Oh,
So I
so
think
you
it-
missed the multiple choice.
I think it was different. I don't think it was necessarily bad. I just think it was kind of unexpected. So it kind of took, I kept expecting to see, okay, this is gonna be my last short response question, and I got some multiple choice I can pick through, and that never happened. So that was just different.
Yeah.
That was great. Do it again. Usually your exams are hard.
Yeah, the
That one,
Maybe
there were definitely
mine
good problems I
actually
still
had-
struggled with,
I
yeah.
had multiple choice this semester, but I don't know why. I was writing this exam. I guess I started doing the longer and like essay type of question, and then I guess at the end I thought, oh, this exam is already too long to add the multiple choice.
Gotcha.
Yeah. Yeah, so the first question, okay, because, yeah, and this question, I heard you, you guys comment, this is kind of repetition and tedious type of question, right? But I just needed to make sure you know how to do those derivations in assessment. Yeah, so the first one took too long, yeah. Sorry about that. But that was 5 points, and all the other questions, I think they were about the same amount, right? You guys need to know how to do like exam strategy, right? You have to go do a pass and look at the questions. Yeah.
Could you go over questions 4 and 5 briefly?
4 and 5. So question here, you have this min-max function. The hint is use reduce to compute min-max first, right? Then map with min-max. How would you apply, let's say we want to get the minimum value from the array, so we can, because one of the parameters for min-max is the minimum value of the array, and the maximum value is the second parameter. We need these values. So you can do array dot reduce. Right? And the function can be math dot min of the two values, right? Something like that. So you need to pass a function, a binary function, to reduce, right? This function should, so math min, so that will get the minimum value between two values that will be taken from the array during the reduce process. And then you kind of do the same thing to get max, right? So you do max, so that will give you the values. Now that you have min and max, you just need to call min max because so two want to apply min max to each of the values, right? So basically you have to do array map, and you need to pass the 3 parameters. The first parameter is the value. So that's the value we're getting, right? The second parameter is the mean, and the third parameter is the max. So this is the idea. Let's take a look at if you just did something like that, I wouldn't even consider syntax, but you guys had IntelliJ to test, right? Let me open IntelliJ here and see the actual syntax and see if there's anything that I'm missing here. That's the general idea. you're using the mean function, passing the two values. This is not actually the solution. Yeah, so here's the solution. More close to what I was doing. So you get the max, you get mean, and then you it's basically normalize, it's the mean max. Max. Right? It takes a double, floats, doesn't matter. Mean is a double, max is a double, and then the mean max, right? So when you call map, you need to pass the function. The function is called mean max. The first parameter for the function is the value you're taking from the array. The second one is the mean. The third one is the max. And I think this part was 3 scores. Getting the max and the mean was 1 score each. Okay, so this is normalized. You can see can check by the, so this is the first, this is the second, the third, the fourth is 0. Let's see if that makes sense. Yes, because it's the smallest value. And 29 is the largest value. So the largest value should be 1. Yeah, it's 1. So it is normalized. Okay. So the solution will be, the official solution is this. Okay. And what was the other one? The next one? 5. 5, the next one. Great. So this one, you have fork, which is a function that takes an int and 2 other functions, and then returns a tuple, applying the first function to A and the second function also using A. And then you have double and square, and your goal is to use filter first, because I only want to apply fork to the numbers that are even. So we use filter. Do something like array dot filter, and you're going to filter by getting the ones that are even. Then you're going to use map applying fork. So map, I'm going to apply fork to each of the elements, right? Then you pass double and square, right? And that's the idea. Let's look at the actual code, which is here, right? Filter and then map fork double and square, and then you just do make string just to show the results separated by comma, because if you don't do that, it will show just the reference of this object. So this should work. Okay. And as you can see, the second, so first the filter will get us 2, right? And we're doing double and square, right? So 2 times 2 is 4, square of 2 is also 4. The next one is 8. So double of 8 is 16, but square is 64, so and so on. 10, right? 20 and 100. So that's the, and I gave 2 points for the filter, 1 for each parameter. That's how the points were distributed. Okay. Basically, I was more interested in just this. If you did just this, you got the full credit. Okay. What else? I liked most of your answers for question 6. Pretty much you all got full credit on this one. Unless I couldn't tell based on your answer that you were justifying how. If you were just explaining what Python is, but from something you probably, if you ever heard about Python before, you probably Google and maybe copy and paste a description of Python, but without giving me or convincing me that you kind of knew how Python does that. So if you said something about Python is an interpreted language, or also say that's to be more precise, it's a hybrid, but using Python, you're taking advantage of changing your code into a C code that can be fully compiled. So there you have the gain of running the code more efficiently. That was a good answer. You could also have said something like talking about the fact that when you use Python, you can, in key points of the code, you can optimize, explicitly optimize variables declaration. So you use annotation from Python to explicitly define the type of some variables. Just by doing that for some key variables in your code, you increase the overall execution speed. So Python can be something totally transparent, like you don't do anything and let the Python optimize your code, or you can do specific annotations to key variables to avoid the dynamic typing, right? And as I don't know if you guys heard that, but there's some statistics that says that like 90% of the time when you run your code is you actually only use 10% of the code. Like 10% of the code of your code corresponds to something super, like 90% or more of the execution time. So if you spend time optimizing that 10% of your code, you pretty much gain a lot in terms of overall performance. And that's what most code optimizers try to accomplish, but by observing your code while it runs to check which parts of your code is worth spending time to optimize. So if you can do that, let Python figure it out that, or you can explicitly define points on your code using some type annotation to explicitly and statically type some variables. I also liked what you guys answered for question 7. Most of you mentioned concerns about readability, right? And also writability. It's if you're used to write indexing using straight bracket, you will type. You will tend to type it wrong, so you have to. So you're gonna write code using the straight bracket and when you're supposed to use the parentheses, right? So it has implications on readability mostly because most people are used to parentheses and also writability. Some of you also, a few of you mentioned that try to justify the reason why Scala uses parentheses. I like some of your answers talking about orthogonality. So like creating, using parentheses as a common denominator for things that are very similar, like when you call a function, when you define a constructor in Scala, you also use the parentheses to specify the parameters. And also for the array, thinking that, well, it's kind of like you're calling the array passing the index, like a function, right? So I really enjoyed that you guys put some effort to also see the other side, like try to justify why Scala used parentheses, and I think answering using orthogonality or a common denominator for things to be treated like functions, I think was a good answer as well. Question 8, most of you got it right. I took some points if I couldn't see 2 different trees, or if you did derivations that were incorrect. Because you can't go from expression to these A, B, C, D directly. You have to go through ID, identifier first. And you can't go from expression to another expression. There's not this production here. You can go to arithmetic, like addition, subtraction, multiplication, division of expressions, or to an identifier, but you can't go from expression to expression. So I took points if I couldn't visualize 2 different parse trees, or if you did some wrong steps during your derivation. And the last one, I think some of you are confused about semantic errors. I saw some of you writing runtime errors as semantic errors. Those are different. Like for example, an infinite loop. I don't agree that it's a semantic error. Infinite loop is a runtime error, logic error. Okay, so I took points based on some of your examples. Okay, and I guess I saw some of you that took time to actually write an example, like a code, and I wasn't expecting a code for those examples. Just writing what those common semantic errors would be, And most of you answer the most common semantic errors, like using a variable that hasn't been declared yet, right? Or calling a function and the type, argument type and parameter type won't match. It's another type of semantic error. Like trying to access a variable that has a private modifier, another type of semantic error. Depending on the array, if the array is a static array, you're trying to go beyond the bounds, and sometimes the compiler can catch those and interpret as semantic errors. You're trying to index an array without a variable, but using a explicit literal, and the static array has a explicit size defined in compilation time. The compiler can catch those type of semantic errors. Another type of semantic errors, when you have incompatible types, assigning an expression to a variable and the types are incompatible. Most common semantic errors, right? But runtime errors like infinite loop or a function that a recursion without a base case. That's also a runtime error. Compiler can't check that. You usually have to run the code to get the stack overflow, which is a runtime error. So just make sure you understand the difference, okay? Okay, so I guess we end up commenting all the questions, right? I think most of you got this right. Yeah, overall I was happy with the results. Okay. All right. So today and this week, we're going to continue our approach on functional programming. But we're going to look at how other programming languages implement functional programming. We start with Scala, right? And hopefully at this point you guys are more comfortable with Scala and appreciate some of the functional programming features. And let's take a look at a little bit of Haskell. The goal is not to become proficient in any of these languages, just to explore some of these languages and just to see how they implement functional programming. I also want to talk about, it probably will be next time on Thursday, how traditional programming languages like Java and Python, for example, how they are incorporating functional programming as well. So we're going to see functional programming features that are present in Java, for example, and in Python. I don't know where the slides started. Okay, so starting on slide 15, and you don't need to install any software in order to use Haskell because you're going to use for such a short amount of time. So instead of installing anything, just do it online. the examples. So go to resources. You can open the Haskell Reptile interpreter. I have it open here, and you can just use it to do the practices. Okay. So that's my recommendation. In fact, I'm just going to have it open, and I'm going to do a side-by-side to make it easier to illustrate some of the examples. That work? Sort of. Okay, so first of all, function declaration, you use the syntax here with 2 colons, and then X is the type. Then you have like this arrow. So this is the input type, this is the output type. So it's a function that has type X to Y. So F takes an argument of type X and returns a result of type Y. Here's a basic example of an increment function that takes an integer and increments the integer. The implementation comes after, and you use some pattern matching. So Haskell does that a lot, pattern matching. And this pattern here uses a variable, so that's the generic case, you can put it this way. So for inc, so there's only one pattern. That pattern applies to any X, and this is the implementation. So let's go ahead and try to implement this function. So the main is where you write the line of execution of your code, and we can just use print to show the result of a function call. So we're going to do inc, let's say inc10. Let's try to run it. Took forever, but we got 11. Okay, the typing of the function is optional. So if we get rid of this, run it again, it also works, okay? Here's another function, function add, that still takes one parameter, but the parameter is a tuple of 2 integers. Trying to simulate a function taking 2 values. Let's do that. It's going to be here. So add. So input is a tuple of integers, and the output is integer. So add X is implemented as. So in order to get the first element of the tuple, I can use the function first. And the function second will give me the second parameter. Now I can do add. And I need to pass one parameter, which is a tuple with the 2 values. Okay, so I got 5. Just ignore this warning. Didn't like that I used tab here. So let's just ignore it. Okay. We good? Simple. Do some Haskell exploration. So remember curry notation. So in curry notation, the functions, they take only one parameter at a time, right? So how to do currying using Haskell? Basically saying that add is a function that takes one parameter and returns a function that takes one parameter and that function returns an integer. Okay, so you just add the arrows. You can think that all of this, I highlighted here, this second part here is the return type of the function add that takes an integer and returns a function. The return function takes the second integer and returns an integer. But now, when you specify the implementation of the function, you can explicitly name the parameters, right? Now you don't need to do tuples, you can just do x and y. When you call the function, you pass 2 and 3. Right? Let's see if this works. Okay, so we got 5. So for pattern matching, we saw that in Scala. Remember pattern matching in Scala? Use case. This is a max 3. And if x is greater than or equal y and x is greater than or equal z, we return x. So how to do pattern matching in Haskell? Use the pipe symbol. Okay? Let's do pattern matching. Enter, do a pipe. So the first pattern, first case is when x is the greatest, x is greater than y, and x is greater than z. Equals, after the equal sign, we have the implementation, the actual implementation of the function. So far, we were only doing the pattern matching. And we're going to return x. If y is the greatest, otherwise, so there is a specific keyword for that, otherwise. Next example is pattern matching and also illustrating recursion. Why don't you guys implement the factorial? actually, it's a different name. This is the traditional pattern matching. With those pipes, I think they call guards. Haskell called these pipes, they actually call guards. So we have guards here, and now we have pattern matching. So factorial of 0 is the special case. So we put it first, okay, because the evaluation of the patterns is top-down. So if we at some point we're trying to evaluate factorial of 0, this pattern will be evaluated first. If it matches, the factorial will be 1. That's what's going to be returned by the function. If not, so we're going to have factorial of, let's say, n. That's going to be n times, and then we're going to call, recursively call factorial n minus 1. Okay. Now, an example using guards. If you want to use guards to implement, you will say, I want to do a factorial of n, then you do the case matching. N equals to 0, then 1. Otherwise, I do the others. Two different ways to implement that. Both recursive. This one is now using guards. When it comes to I/O, I think this is a personal opinion. I think Haskell adds a lot of complexity just to preserve functional purity, which is, we talked about that. It's the idea that a function, a truly functional programming function shouldn't have any side effects. And I bet the designers of Haskell had a heated discussion about, so what are we going to do about functions that do I/O, right? Because an I/O is considered technically a side effect. So to preserve functional purity, Haskell created this special I/O type that encapsulates interaction with the outside world. The value of type IOA is an action. An action is basically an object that encapsulates some value. So when this action, this IO action is executed, it produces a value of type A. So A is a type A. The action contains this value of this type. So let's evaluate some I/O functions. For example, put str. So it takes a string and forwards it to the standard output. So the definition of the put str function, it takes a string, and the return of this function is an I/O action that does not produce or does not contain a value. You're going to have I/O actions containing value when you're actually reading something from the input. The value that you read from the input will be contained in the I/O action. So put str, you're basically going to use to just print something. Like, let's use it here, put str hello. Okay, so we're gonna have hello. And it didn't even put the new line, right? Let's put a new line. Okay, so at least we have hello in single line. Get line. So get line, you're gonna read a line of text from the standard input, returns the string. Actually, it returns an IO string, the action, IO action, containing a string. Okay, so the main function itself is the default IO program, and this is how main is defined. It's an IO action that does not contain any value. How to use get line? So remember, get line will read a string from the input and will return an IO action. In order to extract the actual value contained in that IO action, you have to use this operator here. It looks like an arrow. So it's not an assignment operator. It's more than an assignment operator, right? Because it extracts the value embedded in the IO action. And then you can save that into a variable. Okay, so let's run this program just to illustrate how IO actions work. Haskell.
An expected do block in function. When you do multiple, this is how you do it. I ran this code before, so if it's read to specific. Is it?
Yeah.
It's working there?
Yes.
What am I missing here? Get rid of this.
Need parentheses on the print statements.
the print statement
You need those parentheses.
if I need them. That's working out. I didn't do anything. Okay. So now let's look at how Haskell deals with this. And after that, you guys will have time to do some small practice using this. I briefly talked about lists with an example with eBNF. Remember that I showed the eBNF for Haskell list. Now let's take a little closer look at how Haskell implements lists. First of all, the type of a list is represented using the brackets and the type of the elements in the list inside the brackets. So it's an easy, short way to represent the type of a list. So there is the call is actually called cons is a constructor for list. So if you do 1, column 2, 3, and basically you're adding those elements and you build a list from scratch, right? You start with an empty list, you add 3, and then you prepend 2 and prepend 1. So basically you build the list. You can use this notation, or you can just enumerate the elements. You can do enumerations like you specify the first element, dot, dot, and the last element. It creates this list by incrementing, starting from n by 1. For example, 1, 2, 2, dot, dot, 5 will give you this list here. You can also do just by giving the first and the second element. If you want to jump by some value that is different than 1, so you need to provide the second element as well. I think this is pretty neat how they provide ways to create those simple lists. So for example, 0, 5, dot, dot, dots, 100. I want to create this list. I just do 0, 5, dot, dot, 100. And what is interesting is that this can be infinite. If you want to represent the natural numbers, you do 0 dot dots without specifying the last element, of course. And the integer numbers, you basically will do 2 infinite lists concatenated. So you can represent infinite sets. Of course, this only works because of the what does it call? I talked about this before. Something evaluation. Starts with an L. It's called lazy evaluation. Remember I talked about lazy evaluations? So what is stored is actually a representation of how the list is built, but Haskell will not run the computations. We're talking about just a symbolic representation of a list, right? It will only compute the values as we need them, right? Start to evaluate and trying to retrieve elements from an infinite list, then the elements will start to be evaluated. But if I just assign an infinite list to a variable, doesn't mean that your program will halt because it's trying to compute something that it never ends, right? So it's just the symbolic representation is stored, and is only when I start retrieving the elements, that's when the computation will take place. So that feature is called lazy evaluation. It is available in Scala, but you have to explicitly tell it to use lazy evaluation. In Haskell, the lazy evaluation is done by default. You can use enumerations also to integers. This is cool, right? It figured out that I'm jumping by 2. And finally, list comprehension. In Haskell, for example, use the pipe to separate the generator and the expression in the generator, right? So this is called the generator. We're taking elements from this list X, EX, and this is the expression that builds the list. So this part here is called the generator. And we can have more than one. And we can also add a test. So test is a predicate function that will apply to the elements returned by the generator before we run the expression. So if we're taking each element from this list, we check if they're even. Only the ones that are even, they will be using the expression. A string in Haskell is actually a list of characters. So you can use a generator to get the characters of a string. You can use a function like isDigit that checks if C is a digit or not. And I just want to print the digits in the string. Digit 1 and 5 will be returned. So quick exercise. What's the result of each list comprehension? See if you guys can figure it out. Right, so the first one is basically squaring the values, right? So what's the result here?
1, 4, 9, 16, 25.
Until 25, right? This one here has a test and 2 generators, okay? And the second generator depends on I.
Oh.
Boa.
So like the first thing printed would be 1, 2.
Let's see. We want so I is taking elements 1, 2, 3, 4, 5. But because of the test, and the test is even, right? So we only actually taking 2 and 4, right? So when I is 2, right? When I is 2, J is gonna be taking the elements from 2 to 5, right? So 2, 3, 4, and 5, right? 2 to 5. And those are the values we're going to combine. So the output will be 2 and 2, 2 and 3, 2 and 4, 2 and 5, right? Next I, 4. So now J is going to go from 4 to 5, right? So we continue here, and we do 4, 4, and 4, 5. So essentially, we're doing a nested loop, right? With list comprehension. Okay? This last example here uses pattern matching for the generator. I think that's pretty cool. So take some time to figure out how to do the last one. This is gibberish. Okay, so the first generator will take one element of this big list, right? It's a list of lists at a time. So the first time it will take this first element of the big list, which is a list containing the tuples 3, 4, right? Now let's look at the second generator. The second generator is basically saying, take from XS only if it begins with the 3, right? So take from this one at a time. So let's take this guy. But you have to take only if it matches this pattern, right? Does it match? It matches, right? So what's the value of X? 4. So 4 is going to be generated, right? Or the expression is just X. Next value taken from this big list will be this other list here that contains 5, 4, and 3, 2. Right? So let's take the first one. Does the first one match the pattern? It doesn't match the pattern because the first element is 5. The second element, the matching pattern
starts with 3. So we're not going to take this guy. Okay? Now let's look at the next one. The next one, the pattern matches. So X is going to be 2, and 2 is going to be the output list. Okay?
So how did we know that that was pattern again?
Because it's how Haskell works. Well, basically, it's a feature, right? When you take from a list, right? And you kind of use literal values. Those literal values, they need to match in order to extract that value from that list. Because we have 3, and 3 is a literal, it only extract that value or use that value if the first element matches 3.
So is it after the list, and then you have the comma, and then you have the 3 comma x? Because you have the 3 comma x there, that's how we know that it's a pattern match? Okay.
Because it's on the left side, right? On the right side, you have the list that you're trying to take elements from. On the left side, you kind of express how the elements should look like, right? Okay, I think there's an activity for you guys to So, activity 14, Haskell practice. You guys take some time and do these questions here. I think Haskell is one of those languages that you hate or you love.
It's gonna take you all day, I'm sure.
It's gonna be, your grade is gonna be greater than or equal 100.
Okay.
That makes it feel good.
Well, see, I
Today
actually,
is not a
see,
I'm patient.
I saw my grade, and then I saw that I matched with the class maximum, and I'm like, wow, I know Malcolm did more than me,
Actually,
so
what
when did he
was the
screw up?
average?
And then I found out that his isn't graded yet, and I'm like, dang it. I thought, oh, how the mighty have fallen for once, but alas, no.
Don't worry, don't worry.
Yeah, you know, it says us still. 30 is a 75. You're right. Yeah.
So. Somehow, like, not that bad. It feels like it's
Okay, so the first one is easy, right?
Yeah, see? Yeah, I don't like it.
Right? You can actually
Would you just include one?
test. Let's test this.
The second one is counts.
It's not even, the rest of these are even, so it's not a two.
One doesn't
One.
follow, one doesn't follow the rule from the
I think
first
it's
part
just
of
when
the
it stops, so you'll
list
get the
comprehension.
two, you won't get the negative, you won't get the zero. Makes sense.
Okay? And the next one,
Is anything anymore? I don't think so.
we're going ascending, so 10, 8, 6, 4, 2,
I gotta stop you.
and we stop here, right?
Yeah, I pasted two. Interesting.
Oh, I see around everything after that is like the filter.
It has to be modules.
That's the argument in passing before you. Yeah. It's like, I'm gonna do this.
Would it be 6 though, or would it be C?
If this works. Yeah, yeah, yep. So it's like this one, what he said. It's like- Theories.
3 squared.
So I like to read it.
Not this way.
Well, I can't.
We're going to do this.
3 squared is 9, right?
Yeah, that's why we got a predicate,
Would
so.
be 9.
That's why why would they put the predicate after the? Oh, because it's lazy, now I understand.
Up here?
So mod, that mod is studio code, so I can't run it.
This
Oh, it has to be a
apostrophe here is in order to use the operator in infix notation. Otherwise, you have to call mod 3.1, right? Or, sorry, mod x3. So in order to use infix notation to put the function in between, you have to use this apostrophe. We don't need 10 on this.
Yeah, wouldn't 100 be? Mod 3 equals 1.
Oh, it goes to 10, okay. Yeah, that would be.
Doesn't it? Huh?
Maybe it's 7.
Oh,
No. 7, the next one.
8, 64, 9.
Yeah, it's 10, yeah.
Yeah, okay.
All by 3, right? So 1, 4, 7,
64. 64 would be
7, 3, yeah.
So are you guys able to get this mod operator to run? Okay.
60. Wouldn't 64 would be in it too, right?
So the values for x, let's put it here, is going to be 1, 4, 7, and 10, right? The values for x that has this test, right?
I think you're right, Sebastian.
I don't think 7's in it, and I think 8 is.
The
Because
7 mod 3 is 1, right?
7 times 7 is 49, and 48 is 48 divisible by 3.
Now the test, you have to do the test on the values of x. So you take 0, 0 mod 3 is 0. 1 mod 3 is 1. So we get 1 and we square 1. So the next one that will have mod 3 equals to 1, you add 3 to 1. So 1 plus 3 is 4. 4 square 4, 16. 4 plus 3, 7. That's the next one that will have mod 3 equal to 1. 7 squared is 49. Then 7 plus 3 gives us 10. That's the next one, right?
8 is in it though too, because 64 mod 3 is 1.
63 is divisible by 3, so 64 has to give you mod 1.
Yeah, 64.
Oh, so 8 would work.
So you're only modding 0 through 10 now. Actually,
But it's,
But 8 mod 3 is 2.
Oh,
That's
Yeah,
all.
8 mod 3. So 8 mod 3. We have to chop the square mod.
Aha!
yeah.
Aha!
I don't like this.
He caught you.
When in doubt, use the interpreter here, right? There are commas.
It's actually more like more like hello.
Okay? The interpreter is right. Without running the code, oh no. It's the output. So when you see a char within brackets, that's a string, okay? This function takes an int and returns a string. It uses guards based on the value of n, right? Okay, this function and, it will perform an and on a list. So if you have true, 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 end of that is true. If you have only one false on a list of true and false, that's false, right? And this list has only 2 values. N mod 2 equals 0, n mod 3 equals 0. So it's checking if the value of n is a multiple of 2 and 3. When that happens, the end of that will be true. And we're going to return xy. If it's only a multiple of 2, we return x. If it's just a multiple of 3, returns y. Otherwise, show n. That's what we. Okay, so show n. You have this g list. G is another function. I guess we need to do g first, right? What is g of 0 to 4? It applies the function to each of the elements of the list. So we're going to apply f to 0, then to 1, to 2, right? So when we apply the function to 0, what do we get? xy, right? building this list, right? True one. Show n, right? So show n is going to actually show the string containing the value, right? So basically, show n is going to convert the integer to a string, okay? So now 2 is x, right? 3 is y.
And 4 is 4, right?
I'll say this is the output. Huh?
Yeah.
Yes.
4?
Yeah.
Oh, you're right. 4 is multiple of 2, sorry. X.
It's supposed to be 2 and 3.
Okay, so let's verify. Okay, got it. There's some functions that operate on lists. Basic, like length, get number of elements. You can get the head, the tail of the list. This one is the one that adds a to the head, so prepend a to the list. Reverse the list. Indexing, look, and you guys thought that Scala parentheses was bad for readability. Look at Haskell now.
Exclamation, exclamation, I.
That's horrible. That's how Haskell does indexing.
Well, because A plus plus B makes sense, but
Yeah, I like this. I don't like
thinking that that's like make a list
God's name
of
would they do that?
I factorial factorial.
There had to be more readable combinations they could have used. Other languages like this.
Ouch.
I don't know. I think sometimes designers they just want to do something different to like put a character on the language or their mark, right?
Give it some
the only
flavor.
one that does exclamation, right?
Give it that spicy flavor.
Big I.
I mean, it's kind of like people like, there are languages that don't use equals for assignment. Because like someone's like, boy, it was a really bad decision way back when we used equals for assignment, because that's really confusing.
Let's use an arrow.
But then like everyone's so used to equals now that you're like, what do you mean? What is this stupid character combination in between a variable and an expression? I don't get what's happening here.
I agree. It was.
But it's better.
It was a bad decision, and the mathematicians probably hated. It's still
academia, or like do
Yes.
people use this in the real world?
I don't know, I think it was for, a lot came from C. C had a major influence. And I remember that Pascal used the call equal. That makes more sense for assignment and differentiates, and you use the equals as for equality, right? But then C decided, oh, we do a lot of assignments, let's just drop this to gain one typing, right? And if I want to do equality, which I rarely use, I will do equal, right? And I think it comes from, a lot comes from C. That's from C. Okay, let's talk about high order functions. Filter. Remember filter? So P is a predicate and you have a list. So you apply, so you filter the list, right? This is how you do filtering in Haskell. Also, take while, drop while. As long as the predicate is true, you take. And the first time it doesn't satisfy anymore, you stop. Drop, as the name suggests, you drop until you first elements that satisfy P. So those are higher order functions. Do you have any other higher order function here? No. Oh, this one, any. True if P succeeds to at least one of the elements in LST, false otherwise. I want to check if applies to at least one of the elements in the list. And you have all, it has to apply to all of the elements of the list. So higher order functions. Let's see, is there any other higher order function? Of course, map. And let's see, so the function comes first and the list comes after. In Scala, because those functions were actually methods defining the list class, right? You had to apply like you're calling a method from the list, right? Here you pass the function and then the list. Okay, what do you think is this backslash here? An arrow? If I remember right, this is how you do unnamed functions. It's like a lambda. Okay. So basically you're creating this function on the fly, right? Passing to map. This function doesn't have a name. So the name is backslash. So it's like lambda, right? And then this is the parameter. And this is the implementation. Takes X, returns doubles X, and this is the mapping that's going to be applied to this list. So let's try that. Okay, so double all the elements from 1 to 10. Let's get rid of that backslash. Now, should we put a name for that? Double. I guess that's the only option you have. But you could also define the function first. Let's define double here. Let's try to call double. That also works, okay? But if you want to do that on the fly, you need to use the unnamed feature. And you have to do something like that. Filter functions, filtering on the fly here. I'm only interested in the even numbers. Let's do that. Only the even numbers. Here, our friend Fold is here.
You showed up.
So fold L is our friend Fold left. You mean the summation we did in Scala? I know you guys missed fold, right? Oh, you need to pass the initial parameter. So search it up about reduce. Reduce L? I don't know. You just use fold, because fold is more generic than reduce, right? So you don't have a specific reduce. So pure. Okay, so we don't have fold, we don't have reduce because fold is more generic. You can do fold left. And function composition with the dots. So if you want to do function composition, basically it's going to be f of 5, which is just 6 divided by 5 is going to be squared. Let's try that. Oh, 1 divided by x. Is that integer division? Let's find out.
Wait, why did you do that?
We already have F declared and G. Get rid of this. Okay, so let's do something easier. X plus 1. Yeah, okay. So F is applied first. We get 6, and then 6 is squared. The result of F5 is passed to G. Basic function composition. Here's basically an example combining replicate and max. So replicate returns a list containing A repeated int times. Max returns the max of 2 given numbers. So if you do replicate, yeah, so this example is a little bit more complex because, okay, F and G, they both take one parameter. But what if when you do function composition and you know that, okay, they're all in curry notation, but one function, well, both functions return functions, right? So this example is a little bit more complicated, and the way you write that is different. So how about we discuss this next time, okay? Let's stop now. We continue on Thursday, right? Too much Haskell. We need a break.
Haskell poisoning. It's like a nasty Haskell infection.